Let's look at doing some division with Dienes blocks. Suppose I wanted to do 8 divided by 2. This symbolism here is not very helpful, but if I rewrite this with this symbol here, 8 on the inside and 2 as one of the lengths, this symbol tells me there is a rectangle. The value inside, the area, is 8 and one of the lengths is labelled 2. So we know that one of the lengths is 2 and we're trying to find the missing length of the rectangle that will give us this area of 8. So let's create a system of 8 with our Dienes blocks. So we have here a system of 8, and I know that I'm trying to make a rectangle where one of the lengths is 2. So I can make one of the lengths equal to 2, and then as long as I keep that length 2 and I create a perfect rectangle, I will then find the factorised form and find the other length. So I have one length equal to 2 and the missing length is 4, and I can label the missing length. Suppose we wanted to do 12 divided by 3. So rewrite this with more helpful symbolism. We know that the area is going to be 12 and we know that one of the lengths is equal to 3. So with our Dienes blocks I create a system of 12, and here's a system of 12. Now with this system I can't make a rectangle where one of the lengths is going to be equal to 3. It's impossible to do. So what I do with my 10 is I exchange my 10 for 10 ones. So I'm taking this 10 and exchanging it for these 10 ones. I'm exchanging the place value. Rather than being in tens, I'm now in units or ones. And now I have a system that I can work with. I want to make one of the lengths equal to 3. And there we go. There's a rectangle where one of the lengths is 3. And as long as I keep that length equal to 3 all the way, keep that static, then by filling it in, I will create a factorised form of the number and get my other length. So one of the lengths is 3 and the missing length is 4. So 3 by 4 gives me an area of 12. Similarly, 12 divided by 3 gives me 4. 12 divided by 4 gives me 3. Well, if this question had been 13 divided by 3. So 13 is the area, and I'm trying to make a rectangle where one of the lengths is 3. If I had had 13, you would see here when I make a rectangle where one of the lengths is 3, I have one remaining. So I have 4, remainder 1. Let's try something along the lines of 168 divided by 12. So, more helpful symbolism to show us we're finding a rectangle. 168 is the area inside. We are finding a rectangle and one of the lengths is known to be 12. If I take some Dienes blocks and I create a system of 168, so I'm going to create 168 from Dienes blocks, and you can see here I have 168. So in my system in total, 168. I'm trying to make one of the lengths equal to 12. Can I do that? Yeah. So here we go. One of the lengths is now 12. And you can see this length is the base, it's 10. So one of the lengths is 12. In my system I had 168. I've just removed 120. And I have left over in my system 48. I need to make a perfect rectangle. That's what it's telling me to do. So, perfect rectangle. Can I do that? Yep, I've made this so it factorises. I've made it so it has no remainders. And the other length is 14. And again, what if this had been 169 divided by 12? Then we'd see we'd have one remaining. We would have 14, remainder 1. But what does this remainder mean? Well, this remainder, you can imagine this 1 would have to have this length here. We'd have to have this length of 12. So how thin could we make this to make it have a length of 12? How thin can we make 1 to have a length of 12? we make it 1/12. So it's important we get the children to understand this as a fraction. And sometimes it's more helpful to do this with a picture. So if I look again at 169 divided by 12, so I know one of my lengths is 12. I know that I'm trying to find 169. Well, we're working in base 10, so 12 is 10 and 2. So I've got a 10 and a 2. When I hit the base, I have a 10 and a 2, and when I hit the base I have 120, but I'm trying to get 169, so I'm not there yet. So I need to keep going. I'm trying to get 169, I've got 49 remaining. I'm working in 12s. I know that 5 12s is too much, but 4 12s would give me 48. And now I have my 1 left. So I have to make this one bit here, this strip, equal 1. So what is the distance here? It's 1/12 to give me 1.